So in this video, we're going to talk about compositions of functions. And what do I mean by this? Like f inverse of f of x is equal to, well, it's the sine inverse of the sine of x, and that is equal to x as long as x is between negative pi over 2 and pi over 2. Now, why is that the case? Well, we think about it, okay, what type of things can I plug into the sine inverse? Okay, the things that I can plug in have to be things that are stuck between -1 and +1, okay? Well, the only way I can be stuck between -1 and +1 is if that thing, sine x, is stuck between, the x is between negative pi over 2 and pi over 2, okay? So, and then the same thing works if I have f of f inverse of x. This is equal to the sine of sine inverse of x, which equals x as long as x is between, well, what two values? -1 and +1, okay? So for the same reasoning, right, think about, what you can plug in for sine inverse of x. X, whatever I plug in here, that's got to be between -1 and +1. Now, that could be any number, okay? However, when I take the sine of something, it doesn't matter what that something is inside there. We can do the sine of that, okay? So really, all we're looking for, we're just making sure that our x is restricted between -1 and +1, okay? All right, so let's work some problems where we find the exact value of each of the following composite functions. Okay, so what's that going to look like? Okay, so number one, okay, so this first one here, A, we're going to find the sine inverse of the sine of pi over 8. Okay, now the sine inverse of the sine, okay, so that looks more like this first one here, okay. It's okay as long as our x is between negative pi over 2 and pi over 2. All right, so pi over 8 is definitely between pi over 2 and negative pi over 2. Okay, so this is literally equal to pi over 8. All right, so try another one. Let's calculate the sine inverse of the sine of 5 pi over 8. Okay. So when I look at this, 5 pi over 8, 5 pi over 8 is actually greater than 4 pi over 8, which is equal to pi over 2. So this right here, all right, is outside of the interval. So what are we going to do here? All right, what are we going to do to fix this? All right, so let's think about reference angles, okay? All right, so this is greater than pi over 2, so we're somewhere like I take my side, and I rotate over here, okay? This gets me some negative x value and then a y value. So this angle here is 5 pi over 8, okay? So, what are we actually doing here? Well, sine inverse of sine theta is equal to theta, okay? So what else do we know? The sine of theta, okay? So the sine of theta, that's the y value right here, is going to have the same y value over here, except the x is going to be positive, but we don't care about the x because we're looking for the sine, okay? So why are we doing it in this first quadrant? Well, if you think about it, our restriction, okay, for theta is to be between pi over 2 and negative pi over 2. So what quadrants are those? That's this first quadrant here and this fourth quadrant down here. So obviously this one wouldn't work down here. It's not the same y value. So we got to figure out, okay, what is that angle that gets us back to it, okay? So how far over did I go this way? Well, if I take 5 pi over 8, and I subtract pi over 2, I'm going to get pi over 8, okay? So that means to go back this direction, I subtract off pi over 8, okay, from my pi over 2. So pi over 2 minus pi over 8, that's 4 pi over 8 minus pi over 8 gets me 3 pi over 8. So this new angle right here is 3 pi over 8. So what have I just determined here? Okay, the y value is the same for the sine of 5 pi over 8 as it is for the sine of 3 pi over 8. Why is this good for us? Why did we care about this? Because now I can replace the sine inverse of sine 5 pi over 8 with the sine inverse of sine 3 pi over 8. And this is powerful to us because now I know that the sine inverse of the sine of theta is just theta. So this is 3 pi over 8. Why? Because my theta now is between negative pi over 2 and pi over 2. Okay? So it's all about the reference angles here. All right? So we use the fact, okay, how far away we were from this pi over 2 line here. Okay? And then we use the symmetry here to get us back to this, whatever angle was necessary to get us to that point. Okay? Just a couple more. If I want to find the sine of sine inverse of 0.8. Okay. Now if I was going to use this in a calculator, okay, I go to type this in. Let's try it out. So the sine of second sine inverse of 0.8, close parentheses, enter, is exactly 0.8. Now why does that work? Because the input here, 0.8, is between 1 and -1. Okay, so we're between there, so we're good to go. All right. However, say I had a problem like sine inverse of 1.3. Okay. If I try to do this, so I do the sine inverse 1.3, close parentheses, enter, not a number. Okay. So no matter how much you do here, 1.3 is not in the domain of sine inverse x. Okay, so 1.3 is greater than 1. All right, so therefore this is not defined. If you want to put undefined, that's fine too. Okay, so that's typical. You would say undefined here. All right, this is different than finding that workaround when you were doing the sine inverse of that sine there. Why is it different? Because I can plug any number into sine, right? My trick was I just had to convert it to be between -pi/2 and pi/2 for arcsin, sine inverse, right? But whenever I'm doing the sine of some angle, okay, then this has to be, that number has to be between -1 and 1. Otherwise, the problem falls apart. All right, good luck.